All right. With a uniform distribution, remember uniform. What that if we looked at the histogram of a uniform distribution, what it looked like. Now all of the classes, all the columns were approximately the same, so it formed some type of rectangle or square or something like that whenever you looked, if you were to look at the histogram. So it was approximately a square or a rectangle. We did that several chapters back. And then the last chapter, we went over the discrete uniform distribution. Well, it's very similar to what we're doing now with continuous random variables. We know what continuous means, right? No holes, no gaps, contains all numbers in a given interval. So you would think that if we were to look at some type of graph of a uniform distribution with a continuous variable, that it would be very similar, and it is. All right, the formula you may not think that it is if you just look blankly at a formula. The formula is that, and it's a piecewise function, it's 1 over b minus a for some value of x between or containing or equal to a or b, and then it's equal to 0 otherwise. But what would that actual graph look like? Again, it should be very similar to what the histogram looked like whenever we first went over what uniform meant, and it does. This is straight out of your book. See, we have the probability over here on this side, and then for any value between a and b, that probability stays the same. With a discrete distribution, we could have a probability distribution functions. With a continuous distribution or continuous random variables, we have density functions. Okay, so this is a density function. The formula for the mean is very easy. It's just equal to whatever your boundaries are divided by 2. Your that's the door. Let's see how much easier these examples are compared to what we were dealing with. So this example, straight out of your book in the PowerPoints, so you don't have to copy it down, you can just look at it. Fire department records how long it takes each of his trucks to reach the scene of a fire. Suppose that the distribution of arrival times is uniform with a minimum time being 2 minutes and a maximum 15 minutes. What is the probability that the truck will reach a fire scene within 5 to 10 minutes? So, I mean, you could see how this could be important if someone is running a fire department. The quicker that the trucks get there, the better, right? And so, if we want to know the probability that the truck will be there between 5 and 10 minutes, it says that the minimum time is 2 minutes, the maximum time is 15 minutes, and the arrival time is uniform. So that means the probability of it arriving at any time is going to be the same. Right? 1 over b minus a would be the probability of the truck arriving at any time between 2 and 15 minutes. So where 15 is b, 2 is a, so that would be 1 over 15 minus 2, or 1/13. Okay, so that's the probability at any time. So if we looked at this graph here, you know, for the problem we're working, A is 2, B is 15, so that means the probability at any time between 2 and 15 minutes is going to be 1 over 13. So the probability for 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, all those probabilities are the same, 1 over 13. Probability for 2 minutes and 12 seconds, 1 over 13. Alright, so if we want to know the probability that the truck will arrive between 5 to 10 minutes, then, you know, somewhere right here, pretend we have a 5. Somewhere right here, pretend we have a 10. So what we actually are figuring out is the area of this rectangle that's formed. We all know how to find area of a rectangle. Length times width. So what would, we know what the length is. It's the same. It's 1/13. What's the width? 10 minus 5, right? So our probability is going to be equal to 1/13 times 10 minus 5. So that's a lot easier than what we've been doing. So that's 5 over 13. That's the exact probability. That's the probability that the time is going to be greater than or equal to 5 minutes, less than or equal to 10 minutes. And if you wanted to get a decimal, you could. 5 divided by 13. So it looks like about 38.5% of the time, the fire truck will arrive between 5 and 10 minutes for this particular fire department. Now the only thing that would change would be, you know, your time frame. For this problem, 1 over b minus a, the probability at any time is 1 over 13. So what do you think I should get if I took the probability of this entire figure? I should get 1, because the probability of something occurring at any time would be 1, because it said that the fire department, the trucks arrive between 2 and 15. So let's see if that would be true. Well, the difference between 2 and 15 is 13. So if this is 13, and then the height is 1 over 13, 13 times 1 over 13 is 1. Okay, so remember, with uniform distributions, the probability of something occurring at any time, in any given interval, is going to be 1 total.